So assume the three blocks portrayed in this diagram are moving on a frictionless surface. So there's no force of friction between the object and the ground or the surface. And how much force we are applying? That is 42 Newton on directly 3 kg. Okay, so in this question you have to solve the following things: acceleration, the tension in a cord, okay, the tension in a cord, the magnitude of this force, all right. And the third is the force exerted by the 1 kg block on the 2 kg, means the contact force. This is a force that is applied by 1 kg on the 2 kg. Okay, so let's start properly. And how can we find out the acceleration of the system? So system contains everything that you see in this diagram. So this is our system. So when we will draw its free body diagram, so that is very easy. So students, for this system, when we will draw the forces in a free body diagram, you have to consider one concept, that all the forces which are internal forces, like this is a normal force and this is a weight, this is a normal force, this is a weight, all right, and its normal force and its weight are balancing each other. And even the force of tension at the both ends of the cord is like this is also balancing each other. So ultimately, what is the force which is not balanced is only remaining this 42 Newton force is the unbalanced force, right? So in the free body diagram, I'm considering this is our system. And if I show you just one arrow upward, then it means that these are all the normal forces, sum of all normal forces exerted on 1 kg, 2 kg and 3 kg. And as well as I will draw the same length of this arrow, which is showing us the sum of all weights, sum of all gravitational forces of 1, 2 and 3 kg, all right. And overall these two are cancelled each other. Now this is a force which is not countered by any force towards left, okay, because the surface is frictionless. And this is our applied force, which is equals to 42 Newton. Hence it is accelerating the system, all right. So if we apply the Newton's second law, so F is equals to ma. So what is the force of a system? That is 42. And what is a sum of all masses, which is 1 plus 2 plus 3 is 6 and is a. So you can find the acceleration of the system is 6 7s of 42, so 7 meter per second square is the acceleration of the system, all right. Every object in the system is moving with the same acceleration. Now let's talk about the second question, that is the tension in the cord that is connecting 1 kg and 2 kg, all right. So for this I will draw once again the free body diagram, but of this mass. So for this 3 kilogram, we see there are four forces exerted on it. This is a one force, that is a normal force, okay, on this 3 kg, and which is balanced by the weight, all right. So let's say m3g, okay. Because this is a horizontal surface, that's why these two are balanced. But what about this applied force? It must be greater than the other force which is in applied in this direction, which you know is the force of tension, or you can just write T, okay. So now the subtraction of these two forces, because this is making, what is the resultant force? This is the resultant force on this, okay, and that is equals to m3a. We want to find out the tension, so 42 minus T is equals to 3 into 7, and 42 minus 21 is equals to the magnitude of tension, that is equals to how much? 21 Newton. In this direction I can call it negative because towards left, but on the other side it is positive 21 Newton. So the tension, magnitude of the tension is 21 Newton. Now students, the last part of this question, you have to calculate the force exerted by the 1 kilogram of this mass on this 2 kilogram of this mass. All right, both are placed on a frictionless surface. Well, the string is connected with 1 kg. So on a 2 kilogram of the mass, there is a no force of tension. So there is only one force, that is a contact force. All right. This is a force that is applied by 1 on 2. All right. And that force must be equals to the mass of the second block times its acceleration. Simple is that, because the other two forces on this block, as I already told you, that this is a normal force and this is a force of gravity, are already balancing each other. So this is a contact force applied by 1 on 2. Okay, so that must be equals to the mass of the block 2 kilogram times acceleration 7. So this force is 14 newtons. All right, so question is solved. And remember that the same is the force applied by 2 on 1 but in opposite direction, so that is negative 14 newtons. All right, so take care, bye.